Back guys, we're going to do 3 more here. So we're going to look at 82. Keyword, local maximum. And in your brain, you should be thinking the derivative changes from positive to negative. So what's nice, they gave us the derivative. That is the derivative. And since this is a calculated problem, I'm just going to enter that as y1. So let me punch that in. And I want you to note the smallest value of x is negative 2.314. The largest is 1.234. So when I'm graphing this, I'm going to set my window to go from negative 3, my x min negative 3, and my x max to be 2, because all of my answers are between those two. And again, to be a local minimum, I want to see where the derivative changes, or local maximum, excuse me, positive to negative. So I don't need to see the whole graph. I just need to see where it crosses the x-axis. I'm going to do my y min, y max from negative 3 to 3. You could go bigger or smaller. I'm just going to pick that. As I graph, where does it change from positive to negative? I see it. So let me show you what my graph looks like. Show you what I'm seeing. So where does it change from positive to negative? It's that. So I just need to find that on my calculator. So I'm going to do second trace, which is the calculation. And I'm going to do the 0, number 2. And it asks me to pick something to the left of it. I'm going to just punch in 0 and hit enter. And then to the right of it, I'm just going to push 1 and enter. And then it tells me guess. I'm going to hit my left arrow till it's just somewhere nearby. And I get 0.3501. Bam. As easy as that. So just realize it's the derivative changes positive, negative. They give me the derivative. I just graph it. That's an easy problem. 83. What is this? Okay, this is velocity. And what are they asking for? The distance traveled from 0 and to complete stop. Well, to complete stop, that means velocity would have to be 0. And we see that it happens at 8. Right there. So basically, they want the distance traveled from 0 to 8. Now, normally, the distance traveled, let me change colors here, would be the integral of the absolute value of the velocity. But since the velocity here is always positive, you don't need the absolute value. So in this particular case, it'll be the same as the integral without the absolute value. And that's just going to be the net area. So I'm going to approximate the area, and I'm going to just count squares. Now each square, one square is 10 by 1. It's going to be 10 feet per second times second. So it's going to be 10 feet for each square. Let me zoom in here, and I'm going to actually number these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now I consider this pretty close, so I'll call that 16. Now these two together, to me, make 1, so that's 17. And then these two together make 1, so that's 18. And then, let's see, I will do these two together make 1. I'll call that 19. And then this one and that little piece together, I call that 20. And then I have 2 more pieces left. This one and this one. And so those together make a little bit more than 1, but those two I will call my 21st, or 21. So I think it's going to be less than that. So 21, each box is 10. So you multiply that, that's 210 feet-ish. And look, magically, that one is pretty darn close. So we do a net area to find the integral. All right, let's take a look at this. We want to know when f is concave down. So in your brain, you should think the second derivative is negative. We have the first derivative. How can we find where the second derivative is negative? Well, in your calculator, you're just going to graph, put f prime in for your y1, but we want the derivative of y1. Now, some of you already have programmed in y8 the derivative of y1. So basically, in my calculator y8, I'm going to go math 8 to take the derivative, plug in x with respect to x. My function, I want the derivative of y1, because that's where I plugged in f prime. So I put that in for my function. And at what values do I want the derivative? I want all values of x, so I put at x equals x. Now, I want to graph y8. I don't want to graph y1, which is my derivative. I just want the graph of the second derivative. So I go to the equal sign and make sure that it's highlighted. And then I go to Windows, and they tell me my x goes from negative 1.5 to 1.5. So my x min, I put negative 1.5. My x max, I put positive 1.5. And I want to know when the second derivative is negative. Windows-wise, I don't know how high and low to go. I'm just going to punch in some numbers. So I'll go negative 10 to 10, just to give me a decent size window. All right, it's graphing right now. I'm going to show you what the graph looks like. I'm getting a graph that looks roughly like this. So when is the second derivative negative? Right here and right there. So I need to find that point, and that point. And it's going to be the highlighted pink regions. Now, look at my graph. I can tell just by looking at the graph, it's this. I mean, look at your graph, look at your marks. Clearly it's that. It doesn't fit any of the other ones, so we can stop there. If you want to actually find these 3 points, you can, but I think it's a waste of time. That's it for number 84. And we're done with the session.